In this video, we're going to start with the part we created in the modelling section of this tutorial and show you how to calculate the toolpaths for it. We're going to begin by creating an additional vector that we'll use as part of our toolpath boundary selection. Then we'll calculate a profile toolpath to cut out the holes at the top of the sign, 3D rough and finish all the dimensional areas of the sign, V-carve the text into the bottom before doing another profile toolpath in order to cut the sign out. Let's go into Aspire now to begin. If you've just worked through the modelling section of this tutorial, then you should have a part you can see which is similar to the one on the screen. If not, then you'll need to open the file. To do that, we're going to come up to File, Open. From the project folder for this example, select the file coffee sign model.crv3d and hit the Open button. Then you'd come up, click on the icon here to tile the windows so you can see the 2D view on the left and the 3D view on the right, and we should be at the same starting point as we are in the video. Before we go over to the Toolpaths tab, I want to create one additional vector. I'm going to take this vector around the outside of the part here, come down and click on the offset icon. I'm going to offset that outwards by a distance of 0.15 inches. This is a bit larger than the radius of the tool that I plan to use for the 3D roughing toolpath. I'm going to hit offset and close. We're going to use that vector as part of our boundary when we calculate the 3D roughing and finishing toolpaths to make sure that the tool can roll all the way down the outside of the part, as normally the software will stop the center of the tool on the line. So in this case that would be fine for the areas that are in the recess and the dish, but means that I would have a problem around the outside of the part potentially. So by giving that a small offset there, that should work perfectly now. Let's just click to deselect, come up and click on the icon to switch to the Toolpaths tab. Before we calculate any toolpaths, we want to check our material setup, so we're going to come over and click on the button that says Set at the top of the Toolpaths tab here. We can see we have our material Z0 set to the top of the block, which is fine. Thickness of the material set to 1 inch, which is okay. My XY datum is in the center of the job, and I like to quite often use that when I'm designing a part, but when I come to machine it, I typically prefer to use the lower left. There's no right or wrong choice for this, it's just whatever works for your particular setup. In this case, I'm going to switch to the lower left corner. We can see that's indicated here by the red square in the 2D view. So now everything will be datumed from this corner here, so that all the X and Y coordinates will be positive when we cut this. For the model position in the material, I'm going to make sure that this is pushed all the way to the top, so the gap above model is set to 0. That's because we're working on the assumption that we've pre-finished the flat area of our material here so that we can machine down into this without needing to actually cut this flat area with a toolpath. Next, we check our rapid gaps and our home position to make sure these are all safe values for what we're doing, and we can go ahead and hit OK. If you're planning to cut this part yourself, you need to ensure that all the values you enter for your material setup and all the toolpath parameters are appropriate for your particular machine, the material you're planning to use, and the tooling that you have available. For our first toolpath, what I want to do is cut out the 2 holes at the top of the sign here that we're going to use to hang it. So I'm going to select this circle on the left, hold Shift down and select this circle on the right. I'm going to come over and click on the icon to create a profile toolpath. Start depth is going to be 0 at the top of the job. Cut depth is going to be 1 inch. We're going to cut all the way through the part. I'm going to hit select from the tool area of the form, and from the tool database I'm going to select a 0.25 inch end mill, a 1/4 inch end mill, and I'm just going to take the default values for this, click the OK button. But if I want to, I can come in and hit edit, and for this toolpath only I could make changes to these values. If I change them in the tool database itself, then they'll be permanently edited. Here I can just come in and say that I want to take a pass depth of a 1/4 inch with this tool rather than 1/8 inch, and just have to know that that's appropriate for the material and the tool I'm using. So now I'm going to hit OK. We can see now it's going to cut through an inch thick material in 4 passes. I want to choose the option to cut inside those 2 circles. I want to machine on the inside of these, so I'm going to choose the option there to cut on the inside rather than the outside. Don't need to worry about any of the other settings here. I'm just going to call this Profile Holes and hit the Calculate button. Now we can see the software's automatically opened the preview window for us and is showing us the preview block of material. If I maximise this in the 3D view, go to the ISO view, we can see the toolpath there. And now I can click on the button to preview the selected toolpath. The software will show me exactly what that's going to cut. If I want, I could even remove this waste material by double clicking on it. If we double click on each of the cores of those holes there, then they'll disappear, and we can see that's how the part will look once we've cut those two pieces of material out and removed them. Next, I'm going to close the preview toolpath so we go back to seeing our 3D model. I'm going to come up to View, Tile Windows Vertical. Next, I want to select the boundaries for my 3D roughing and finishing toolpaths. So I'm going to click in the white space in the 2D view in order to deselect those two circles. I'm going to zoom in a little by rolling the mouse wheel away from me and select this vector around the outside of the job that we just offset. Next, I'm going to roll the mouse wheel towards me again to zoom back out. I'm going to hold Shift down and select this vector, the inner part of the border. Still holding Shift, I'm going to select the larger circle, the circle in from that, and the circle in from that. Now with these boundaries, the software is going to create a toolpath between the first two vectors, between the second two vectors, and then inside this vector here in order to cut all the parts in the dish. This is just going to make sure we're only cutting the areas we need to with our 3D toolpaths. Let's just hit F in the 2D view in order to fit the window back in, or to fit the view back into the window. Now I'm going to come over and click on the icon to create a 3D roughing toolpath. I'm going to hit Select, and from the tool database I'm going to choose the 1/4 inch end mill, and I'm going to hit OK. Next we can set a machining allowance, which is a skin of material that will be left on the surface after the roughing toolpath has finished. This makes sure we have some material left for the finishing toolpath to cut and keeps the tool away from the finished surface to make sure it doesn't chip it. We can choose whether we want to Z-level rough or 3D raster in order to cut the part. In this case I'm going to do Z-level cuts, raster X, profile set to last, boundary vector offset I'm going to set to 0. We did our offset here to allow the tool roll down the outside edge, but I don't want it to come past the edges of the internal areas of the sign here. So boundary vector offset 0, we'll call this toolpath 3D roughing and hit Calculate. We can maximise the 3D view again. We can zoom in if we want to take a look at the toolpath itself, or normally the easiest thing to do is just to click on the preview selected toolpath button and see how that will look when we've actually cut it. So I'm happy with that. I'm just going to click back to the ISO view, go up to View, Tile Windows Vertical again. Now with the same set of vectors still selected, I'm going to hit Close on the preview toolpath form. I'm going to come up and click on the 3D Finishing Toolpath icon. I'm going to select from the tool database, click on the ball nose tool and pick a 1/8 inch ball nose tool. Hit OK, hit the edit button, and we can override the values for this if we think we could cut our material a little faster than default settings. Hit OK. Given the shape of this job, I think it would be good for us to use the offset strategy. The offset strategy will follow our boundary vectors and offset using the step over value in order to create the toolpath. Because we've got a pretty well defined border area and then these circles within the middle, then I think that's going to give me a good finish. I'm going to set the boundary vector offset to 0 again. We have already pre-offset the vectors as we talked about, the ones we need to. We'll change the name to 3D Finish, hit the Calculate button. Software will take a few moments in order to calculate this toolpath. It's a fairly large part that we're working with here. Once it's done, we'll see the toolpaths appear in the 3D view. We can maximise that again. Once more, we can click on Preview Selected Toolpath, and the software will show us how that's going to look after we've cut it with that particular tool. If we're happy with the detail, then the last toolpath I want to create is going to V-carve the text into the base part of the sign here, and then we'll be able to calculate our cutout toolpath. So let's click on the Close Preview Toolpaths form. going to come up to View, tile the windows vertical again. Now I'm going to select the Magic Beans text, and that'll deselect the other vectors here. Come over and click on the icon to V-carve those. Our start depth is going to be 0 because the part is pushed all the way to the top of our material. For the tool, I'm going to hit Select, look at the V-bits, and what I want to use is a 120-degree V-bit, a specialist sign making tool. We don't have one of these specified in the tool database, so I'm going to add one. In this case, an easy way to do that would be to copy the 90-degree V-bit and then edit the values for it. So I'm going to select that, hit copy. The first thing I'm going to do is to check and change the name and change the values for it to make sure they're correct. So for the name, I'm going to enter 120 degree. It's going to have the same diameter, and I must immediately remember to come and change the angle in here, the included angle, to 120 degrees. If I change the name and don't change the angle, then that can create a very confusing situation, because I would believe I was selecting a different size tool or a different shape tool than I actually was. In this case, if I hit apply, I will get an error message telling me that the current pass depth, which we had set for the previous tool, is too much for this tool. For that angle and that width, the maximum depth of cut for this tool on a single pass is 0.361 of an inch. So I'm going to hit OK for this, and I'm going to edit the pass depth to be 0.3. Now if we hit apply, we shouldn't get an error. I could make any other changes I needed to with regard to feeds and speeds and step overs. If I'm happy with that though, I'll do one final check. Name, V-bit, 120 degrees, included angle, 120 degrees, diameter matches the name as well, so then I can hit OK. Now we can just come down, edit the name if we want, hit calculate. There's our toolpath. Again, we can click on preview selected toolpath to see what that's going to look like. Zoom in a little to check that. If we're happy with the way that looks, then the last toolpath we're going to calculate is actually going to be our profile toolpath. What I want to do is just click to deselect the letters. I'm just going to zoom in with the mouse again and carefully make sure I'm selecting the vector that's actually right on the edge of the part here. Let's hit F to fit that back in again. Close my preview toolpath form. I'm going to come up with that vector selected and click on the profile toolpath icon. Start depth is 0, cut depth is 1 inch, which is correct. I'm cutting all the way through the part. I can see that I have the right tool selected, so if I hit edit, I can check the parameters. I'm happy with those. This time we need to set this to cut outside the vector. Previously we were cutting inside of the circles here. Now I'm going to cut outside around that vector there. If we want to, we can add tabs, leads or ramps onto the toolpath for this. In this case, I'm just going to go ahead, change the name to profile cutout, hit calculate, maximize my 3D view, click on the preview selected toolpath and take a look at how that part will be once it's cut out. I'm going to double click on the waste material around the outside here, and now in the 3D view we're getting a really good representation of how our part's going to look when we run that set of toolpaths that we've just calculated. Once I'm happy with the way the preview looks, then I'm ready to output the data to send this to the CNC. We can come down and hit close on the toolpath preview form. I'll select the first toolpath in the list, click on the icon to save toolpath, make sure that under toolpaths to be saved the right one is listed, and then make sure I have the right post-processor selected for my machine or control software. You should only need to set this once in the program. In order to do it, we click on the down arrow and then just look through the list here in order to find the appropriate one for your particular setup. Once we've got all those things, then we hit the Save Toolpaths, give that toolpath a name, an appropriate name, so we remember what it is. Quite often you might want to put some information about the tool size or something in the name of the file to help make sure you set it up correctly on the machine, and then you'll hit the Save button. Then we'd go ahead and select the next one, click on Save Toolpaths, give that an appropriate name and hit Save, and work our way through the rest of the list repeating that same process. Once we've done all that, we can close the Save Toolpaths form, and at that point you should actually go ahead and save the whole file. So if we come up to File, Save As, here in the project folder I'm going to save this file as I've set it up in the video and call it coffeesign-tp.crv3d and hit the Save button and just overwrite the one that's already in there. Saving the Aspire file like this is essential because it keeps a record of our part that includes all the vectors, all the components and all the toolpaths that we've created. That can be opened at any time in the future then, either to review the job, make edits to it, or even use parts of it that you could save or copy into other sessions of the software for different designs. Now let's take a moment to summarize what we've looked at in this video. We started with the model that we created in the previous section of this tutorial. We quickly created an additional vector that we could use as a boundary, then went over to the Toolpaths tab, checked our material setup, calculated a profile toolpath to cut out the mounting holes for the sign, carefully selected the vectors for the different boundary areas for the 3D roughing and 3D finishing toolpaths before calculating those. Then we V-carved the text into the base part of the sign and then finally created a profile toolpath in order to cut the sign out. And that concludes this video.